Our next speaker is Dirt. Not Dirt, is Bob Shaffer, who knows everything about dirt. I think the dirt knows everything about Bob Shaffer. Anyway, I got the dirt on Bob Shaffer, so I'm not going to kiss you, but I am going to give you one of these. Huh? Thanks, buddy. There you go. And you want to take questions at the end, right? Sure. Price tag's still on there. You can return it to law.
Aloha. It's great to be here. Thank you. And thank you to the board of the Tropical Food Growers Association and for everybody who put on this conference. As Ken said, there's a lot of people here. It's a great conference. Thank you so much. So, yeah, okay. Okay. So if we could, maybe we take questions at the end. If there's something urgent, go ahead. But otherwise, maybe we can hear a little better and answer your questions better towards the end. Great to be here to practice aloha aina with you. Our soil is our greatest resource. Our health is our greatest wealth. And we have soil health in front of us today, as soon as Ken gets it up there. And we're going to go through just some of the associations that us as farmers. I'm a farmer, so I've been a farmer all my adult life. I started out as a small farmer in the Midwest in the 60s. And during that time, in the 60s, we had a lot going on. There was a change in farming that was happening. Many things had happened. And in reaction to that, farming was being looked over again, and we were trying to get towards health. And there was the Rodale Association. And in my family, in Indiana, we were completely surrounded by farmers. Mom and Dad had quit farming. They went on to other things, but we were completely surrounded by farmers, and I loved the farmers. I've always loved farmers and still do. I work with farmers on a daily basis. And we were just in this position where farming was changing, and the Rodales were talking about organic farming, Organic Gardening Magazine, and Prevention Magazine. My mother and father took up composting. They took up composting. Now, they didn't build compost like we build it today, but they took up composting, so I'm practicing composting, and there was something about health food. Mom announced to us that we're all health food people now. And so we were going to fight Vietnam War, we were going to eat health food and build compost. So that was my exit out of high school and out of Indiana. I went to college for a little while to be a veterinarian. I couldn't stand it, and I went to California and started small farms. It was really composting that got me interested in soil, because I was building compost out of my high school experience for the farmers that I was working with, my friends. We weren't really farmers at that time, we were gardeners, but I was the composter. I didn't know much about gardening, so I got fortunate and started to have people around me that were interested in compost, but were master gardeners. They were master growers, and they started to teach me a lot about farming at that time. And so, through that process, I started to raise larger gardens, then small farms, and at a certain point, farmers around me started to offer me pay to give them advice. I was shocked by this process, but farming is about learning, and I need to learn every day. I'm here to learn, as a matter of fact. I know you are too, and so we're on the same page. I just wanted to give a little respect and aloha to all of the skill that we have, and this isn't this isn't everything. I try to not mention names because I'll leave someone out, but we have so much support for soil health here in the state right now. Look at the difference between this and 10 years ago. 15 years ago, almost nothing. 20 years ago, almost nothing. We had maybe the first soil health conference about 2001 in Hawaii. The Aloha Aina nonprofit in Maui held the 2001 Body and Soil Conference, where we brought speakers from the mainland. We had doctors from the island, and we talked about soil health. Scott Smith, I believe his name was Scott Smith, was the USDA state soil scientist at the time. He came up to me and he said, "Hey, where'd you get that term, soil health?" I said, "Well, I think we got it from you and the Rodales and from ancient farmers going back all through our cultures, and of course the great Hawaiian people and all of our ancestors, all the farmers that gave us what we have right now to build on." So there is a link between the quality of our crops and the health of our plants that is associated with soil health. And some parts of the farm are better at growing plants, some parts not as good. So we make those comparisons, and we can see that's not all the same. Soils are not homogeneous, either horizontally or vertically, or over time. And so we are always looking to have the plant tell us what the soil needs and what's going on to some extent. And we can see the quality in the crop associated with the health of the soil. Are you accustomed to looking at your soil and relating it to your health? This is the term that we're working with. I've never, because I guess it was the background and the feeling that we got from the Rodales when I was young, that health was in the soil. And so as we start to learn more about soil, we start to refer to it as, yes, the soil is alive. Gaia exists. Gaia is alive. And we then surmised that we had to be feeding the soil. When I would say that I was feeding the soil to older farmers at that time, they'd laugh. They'd go, "Well, what are you feeding?" And I couldn't answer it. I couldn't answer it, and that haunted me and actually drove me back to studying. I was not a good student. I dropped out of college. I couldn't study. I couldn't focus on it. I couldn't understand what I was supposed to learn. But once I got out on farms, I found that I needed to study because I couldn't understand what was going on. So I became a habitual student up to current, and I currently review papers maybe way too much right now. But the work that's been done in Hawaii, many projects, but these three significant projects over time have helped me so much, have helped us as farmers so much in the state. I stand on the shoulders of many people that have given me so much in helping me to understand soils. Okay, you can change it. I don't have a changer, so change. And there's a lot of, I'm giving you a heads up. There's a lot of definitions of soil health. I don't really, I had a slide set up where it showed 7 or 12 different versions of what soil health meant, but I don't think we have to do that. We're gonna keep with the feel of this, that ask yourself about your health. You're probably pretty close to your health, really. You understand it. You understand when we feel good. We understand when we don't feel good. And if we're honest with ourselves, we can really get a pretty fine tuning on what's going on. We may need to go get some help. We may not. But the point is that I don't want to overburden the definition of soil health, as we want to drive towards, okay, how do we get the services out of soil? What I'm looking for as an agronomist, what I'm working for farms, and a farmer myself. I have a small farm in Kona. We raise all the typical stuff: avocados, bananas, mangoes, taro, cacao, etc. And I have 50 or 60 species that we've diversified the farm with, of spices and herbs and all this type of stuff. But we want to drive towards understanding what are the services that I get from a healthy soil? What does it do for me as a farmer, or me as a consultant for farmers? This is where I got really attached to soil health, when I started to learn that by feeding the soil, by protecting and feeding the soil, the power, or the leverage, if you will, that comes from that towards more yield, consistent yield, soils that don't erode, consistent yields and high quality. When I caught on to this and I demonstrated to myself, I do constant trials. Trials do not have to be completely replicated. They do not have to be expensive. You can do trials right on your farm. I do not have any farms that I work with that I don't have constant trials going on. I have constant trials going on my own farm, so we can see where we're headed, okay? I want to try to stay, for clients, I want to try to stay a year or 2 years ahead by my trials. of what we're going to be applying so we can see what's going to go on, or have a better chance at seeing what's going to go on. So it's the services, yes, you can, let's change. It's the services that we're looking for. And in terms of just the essential services that soil health provides to all the soils, not farm soils. For a moment, we're just saying these are the, at least the services that the soil provides to us as humanity, to nature, even if we weren't here. Before we were here, these processes were going on, okay? They weren't called soil health because we weren't here. And the ancients probably understood soil health. Certainly there's great records looking back in history of people practicing cover crop, people practicing manuring, and they were reporting that this makes plants grow better. Maybe they didn't understand the way or talk about soil health the way we do. I think that actually soil health for us is a communication tool as much as anything, as far as the metaphor. Soil health as a metaphor, for me, is a way to talk to my clients and to talk to farmers, particularly farmers that are not, if you talk to them and maybe their cultural practices aren't really in line with healthy soils, aren't in line with producing quality, then we're going to start to talk about health. I'm going to start to talk about health with them because I work on my health, I've worked on my health my whole life, and I can talk to them from a personal place about how health is in the soil. It's because we have, let's go to another slide. We have live animals in the oil. So you can change again. What's the purpose here? Carbon going up in the air. This is smoke, so it's particulate, but hidden in this, and the message to us as farmers, we're farmers, right? Is I'm losing carbon here. Now, what I want to do is put carbon in the soil, okay? And the carbon is really the point of feeding the soil, because it's the microorganisms in the soil food web that we'll talk about, both on the surface, below the surface, that are benefited from carbon. It's their food. So it's part of the principles that we have in soil health, is to protect the soil and feed the soil. It sounds like we're raising chickens, doesn't it? Or puppies, or whatever we're raising, or our children. You have to protect them and feed them. The soil is alive, we have to protect and feed it. So we don't, you can change, we don't want to lose. We've had terrible losses over time, you can change. And this has been going on a long time. There's been 3 major waves of soil erosion over the centuries. And we're trying to move away from this because we don't have to talk about soil health if the soil's gone and eroded. The soil has been absolutely displaced horizontally or otherwise, it is eroded. Okay, we can change. And we've lost any ability. So this is our friend Ray Archuleta. You may know Ray. He's from USDA, does a lot of work with Acres USA, giving presentations. I work in Australia. Ray is always in Australia, giving presentations, and I swiped this slide from him because it's just so graphic. It's not, we don't raise soybeans here, but any crop, it's regardless of the crop, it's the cultural practices. It wasn't the soybeans that caused that, okay? It was the practices from the farmer raising soybeans. The soybeans is a legume. It didn't destroy that soil. We can change.
Looks like chocolate.
Looks like what?
Chocolate.
Yeah, it does look like chocolate. Well, and we can raise chocolate above ground. So this is just kind of starts to be my feel for soil health, okay? This agrees with a lot of, I find that actually, of course, because I study science, I've learned everything from either science or just being on my farm, observation. It becomes one and the same, me saying, okay, these are the things that really count to me as far as the discussion of the term soil health. You can change. And change. Okay, so this topic of soil health to me merges into cultural practices and to what we're really trying to do. We're trying to diversify the farm holistically, and then we're going to start looking for being able to identify the characteristics of a healthy soil. Certainly, this is a great area of practice, and there's, you can change again. When you come to farms, you can get an initial impression on if there's diversity or not. To me, diversity is the entry point to soil health. It's the entry point to getting real productivity on your farm, or taking it the other way, not losing more on your farm. Presentations already this morning had talked about diversification, bringing many varieties to Hawaii, different varieties to Hawaii that we've never had before. Diversification is really important for us. And here's a farm that I created, planned, and made the operating system plan for in Maui. It's a coffee farm, but we've got all kinds of other stuff growing because this helps the coffee and the production of the crop. So we want to imitate nature in our systems development. When you're developing your operating systems plan, whether it be organic or not, I don't care about the system that it's farmed under, I care about the cultural practices. And this is our, change again, this is our highest calling. Here's a farm that's imitating nature as much as possible. This is Santa Isabel in Guatemala. It's a 1,000 acre organic, certified organic farm that's biodynamic, has ongoing composting system that I built for them. It has leguminous trees across the whole 1,000 acres. They've interplanted this now. They actually went to the whole 1,000 acres. These folks had come to California a number of times. I go down there, but they come to California a number of times, and I've taken them around and showed them examples of diversity and examples of how you build diversity into farms. And they went back to their 1,000 acres and cut down 50 or 75% of the Inga trees that had gotten old. They're all one species, or predominantly one species, and interplanted with 23 other types of flowering and fruit-bearing and nut-bearing trees in their coffee orchards to get diversity back into their large farm. Let me change it. So carbon is the essential part of this. We're going to use I'm going to use cover crops, compost, tillage practices, lack of tillage, moderating tillage to a beneficial disturbance and not a destructive force on soils to try to retain my carbon. I don't want it in the air. It's polluting to the air, it's changing our climate. We want it in the ground. As farmers, though, to get soil health, I've got to keep carbon in the ground. You can change. So who are we feeding? Who are we feeding carbon to? It starts at the surface. You've got 9 animals. These animals have mandibles. They're chewing up the organic matter from your cover crop, from your mulch, from your crop's leaves that drop down. Any organic matter on the surface, whether it's from animals or plants, are consumed by these 9. Now, we have them all in Hawaii. Not all farms have the same ratios of each, but there should be a high enough population. The population should be healthy, and the population should be diverse for this to really work. But if it wasn't for these 9 animals and the 4 sets of organisms in the soil, we wouldn't have any food, we would not be here. These are absolutely essential for healthy soils and for us to produce food. I ask farmers, I can be on the telephone with someone that's 3,000 miles away, and I like to ask them at a point of the conversation, hey, if you go out to your field right now and pull back the residues, what do you see running around? Critical question, right? A lot of times the answer is, well, I don't have any residues on the surface. We get rid of all of that. Okay, we better go on to the next question. Next slide. Below ground, the USDA chart, I know this is boring, won't spend much time on it, but basically showing bacteria, fungi, nematode, and protozoa in the food web activity. This was around mid-90s or late 90s in the last century that Elaine Ingham was at Oregon State University, and with 50,000 peer-reviewed science research documents, if you will, reports, they were able to peer-review the soil food web. We could prove that we knew who is eating. It's a prey-predator relationship. It's where energy is flowing. It's how soil organic matter breaks down. It's how nutrients are recycled. It's where pest prevention comes from. It's where the decomposition of toxins come from. It's from the operation of the bacteria, fungi, nematode, and protozoa in the soil food web. I was fortunate enough to start working with Dr. Ingham. She put her first ad up for the Soil Food Web Lab in Corvallis, Oregon. I drove up there the next week. We became partners with Elaine, and I started talking about the soil food web in Hawaii and doing soil food web test here by 2000. Next slide. So we want to determine sort of the level of our health. You know how we can go to the doctor, we can get some blood work, we can do all these things, we can check it ourselves and determine kind of the level of our health. And next slide. And so there are indicators. Next slide. We want to use the indicators and teach ourselves to identify what our soils are doing. Now this is soil from about 1 foot away from each other. Okay? Okay, those two soils were taken from just about this far apart from each other. So on farms, this farm has perennial trees running in rows, and then there's the tractor row. So there's where the tractor drives, and there's where the trees are. So I go underneath to take soil samples. I go under and to examine the soil. I go underneath the trees, and then I go out in the tractor row, and I take split samples. Two different worlds. Two different worlds. Where would you hope the best soil will be? Yeah, right underneath the, yeah. So the soil on the left with the lighter color is underneath the trees. This is always bad. You can see the roots of the trees are there, but the soil out in the tractor row, excuse me, I haven't been talking to the mic enough. The soils in the tractor row have not lost as much carbon as they have underneath the tree, because the soil on the left has a lot of herbicide that have been used over the years, okay? So anything that removes the plant, that removes the root, causes the carbon levels to go down, causes the humus levels to go down. Right where your trees are, backwards to me, okay? So I start to work more with compost. I start to get cover crops underneath the tree to try to get roots back in the ground to where I can get some carbon deposited in the ground, where I can start to get some channeling and improve the structure right underneath the trees. So this is also to say that soil health is not the same across the whole farm. We know that our soils vary, right? And so the health of the soil may vary right in between out in the row or underneath the tree. Next slide. So we can measure soils at the lab or on our own, and next slide. And we can take many types of measurements. I like to start with just non-lab stuff that you can do yourself to check in, see what degree of soil health you have, how the quality of your soil is doing. We do a history, we go out and look, do an exam of the soil. We can change this again. And we can start to get a view of what's going on with the soil. Now, again, at the bottom, we can use handheld meters or go to laboratory analysis. There are great handheld meters now that we can check calcium, we can check potassium and sodium in particular. I can measure the EC, I can measure the pH, I can measure the sodium levels with handheld meters and avoid the time that it takes and the cost it takes going to the lab. Next slide, please. So I'm going to look at the diversity of the animals on the surface, the earthworms, the ground cover, all these things to give me a feel for what I need to do. I'm going to use soil analysis, of course. I'm going to use all my tools available, and including all the assays that I can do in the field. Next slide. Visual inspection of the field is real important. You might see right away that if I've got a little coffee tree and he's sitting in a mud puddle like that, you notice what they're doing. They're coming around it and they're weeding by hand or with a flame weeder, and it's taking away the plants right around this little tree and even allowing more standing water. This soil was not draining well at all, and of course the roots become to where they went right down to where the water there's not enough oxygen. Coffee is a high oxygen demand tree, as avocados are also, and it absolutely ruined the root. Now here's, so I work in Australia for over 10 years now, teaching soil health. Both the Landcare Soil Care group employed me to go, over 10 years, employed me to go to every city in Australia, every farming district in Australia, and we gave 2 and 3 and 4 day presentations on soil health to large groups of farmers. These people are highly enthusiastic about soil health and need it. They have very old soils there that have huge problems. And this is the group that I worked for. You can go to the next slide. And they have a little videos that you can get that I just thought were interesting to see. This isn't all of our crops, and this is not based in Hawaii, but you can get these online. And this is simply going out to your field, and they'll give you some instructions on both how to take samples in the field and then kind of the relative ranges of what you find and what that might mean. Now, you can go to Dr. Crow's lab, you can go to SITAR, there's other agencies in Hawaii that will do soil health exams for you, but we can do them ourselves also. Next slide, please. Next slide, please. So we're going to talk about the development of soil health now, get into the meat of what we're doing. We're going to protect the soil and we're going to feed the soil. It's pretty simple, right? There's much nuance to this, and I'm not, we are going to talk about some of the nuance, but protecting and feeding the soil, we're going to minimizing disturbance. So many farms, particularly I worked 30 years in California, I've been 30 years working in Hawaii, I crossed over for a number of years, but in California in particular, we have a very heavy tillage culture. Lots of old soils, lots of clay, and so the method is you go out and you bust it up, you grow your crops, and then it goes back tight again, you've got to go back and bust it up. They never get to the point of understanding that you don't have to do that. I can break it up other ways, and that going in with large equipment and tilling the soil, we need to minimize the disturbance of soil to get its health back. And one of the ways to do that, of course, is to go to cover crops, go to better mineral levels that help you with producing the crop without having to have the tillage be the thing that loosens your soil. Next slide, please. This is sort of my shtick. I've got 3 groups of soil culture practices that I can use in a system to produce healthy soils. I've got 9 soil surface animals, 4 functional groups below ground, and the 7 services that are produced by soil organisms. And I can overlay it with treatments, I can overlay it with foliar sprays and fancy use of nutrients, good use of fertilizer, other technique. But that's over the top for today. We're just talking about soil health and how to do it with nature rather than going to treatments and practices. There is some philosophy to kind of underpin this. Blaming, farmers are real good. I've lived with farmers all my life. We're very good at blaming the weather. The pest did it, the weather did it, the dog did it, something did it. It's never us, it's never the soil. Well, let's have another slide. There is the view that pests only really become a problem. And I've experienced this so much. I've been around farming long enough now to see these cycles, and it's empirically true that as the soil health is lesser, your pest problems are more, especially soil-borne diseases. I never had diseases as an organic farmer when I was small. When I started to work for conventional farms, which was different to me, I had to learn conventional farming. It's different than the origin point of organic farming where I grew up and what I practiced. But I felt the need actually was in conventional farms. And I just felt I wanted to be involved with these farms. They had great crops. I wanted to be involved with conventional growers. But it was very hard at first. And they have so many disease problems that I find now at the end of the day, where I never intended to be involved with giving any advice about diseases or preventing diseases, it's the whole picture now. Our disease pressures are increasing, and our need to prevent damage to our crops is increasing, and that's where I end up. Next slide. Photosynthesis is where we start, right? Next slide. This is where we're going to get the carbon. So plants are the primary producers on Earth. If we're only growing the few plants, maybe we're just growing coffee, maybe we're just growing macadamia, it's insufficient to really get the volume of carbon back into the soil that we need to be healthy. Next slide. Because we've lost so much too. There has been significant loss of carbon from the soils, mostly from tillage, but from, in general, practices that disturb the soil, going to lose carbon and not putting enough carbon back in. Next slide, please. Next slide. So there's different forms of carbon. And here are roots that I pulled out of the ground, and you can see the soil that is adhering in the rhizosphere. The rhizosphere is that area around the root, about 1 millimeter roughly, but it's the zone of influence, as it's called. It's the area around the root where carbon, nutrients, proteins, enzymes, minerals, other materials are being exuded by the root to feed the organisms that are living in the rhizosphere. Now, what's clinging to that root? You can see the aggregation, you see the crumbly look nature to it. The aggregates are forming around that root because this is where the action is. This is where the carbon is coming out from the exudation in the plant, is forming this type of carbon called humus. Next slide. Around the root. Needs to be a transition. And integrating your cultural practices, your organic matter management, your nutrient management, and your tillage management into a system is important. Feeding the soil, growing large volumes of diverse plant matter is the way to get carbon and feeding quality back into our soils. So we have a lot of species of plants that we can accept the name for. It's hard to identify plants, and there's a lot of disagreement in the world, but we've got at least 298,900 accepted genus and species of plants. And so how many are we raising on our farms? We're falling far short on diversity a lot of times, and there's a lot of opportunity. Next slide. Okay, next slide. Here's an attempt at biodiversity. This is in Maui. This field is 17 years old now and completely grown up with the coffee trees. The coffee trees are so little in this and hard to see in this. So I put the little red circles around the coffee trees. This was the point. We were raising a coffee field. But I planted we planted Arachis pintoi, the prunus peanut, a little too early actually. You want to wait and plant your prunus peanut after you get the coffee up a bit, because it becomes too aggressive. However, the soil is covered with a legume, the coffee's there. The prunus peanut is not a host to plant parasitic nematode for the coffee, so this is a non-host cover crop that we're putting in specifically for the coffee there. I don't want parasitic nematodes to be fed by my cover crop and then attack my coffee. And then on the right-hand side, we put pigeon pea, which is about a 3 or 4 year legume, upright legume. On the left, we put Glurcidia. Those trees are still there. And this was repeated all the way across the acreage. And so there's windbreak, there's alley cropping, there's some diversity built into it, and there was some food came out of it while we were raising the coffee. Next slide, please. There's a lot of below ground diversity. Next slide, please, that we can count on. And in terms of, I said earlier that really diversity and biodiversity is the way into soil health. And this chart is just trying to show that almost everything that threatens our degree of biodiversity is really, it comes from soil damage, compaction, erosion, sealing, pollution, decline of organic matter. These are all a great threat to biodiversity, and we need the biodiversity to get to soil health. Next slide, please. Next slide, please. They got back in there again. Okay, so I'm just to looking, okay, we have such fantastic species of earthworms here in Hawaii. I used to ask, I gave a presentation to all of the extension agents in the state that came in Hilo about 20 years ago. It was the first PowerPoint I ever made. It didn't work well at all. And my question that day was, could we identify all the earthworms in our soil system at the time? Wasn't much response. We need to pay attention to the earthworms here, as it's the largest animal in the soil resource. They are imported worms. This is Amanthus criticus. John Blakemore is a world expert on tropical earthworms. I've talked to him. Next slide, please. And these are fantastic animals. You probably see them. They're very active in our soils. This is from Australia. We have a lot of earthworm. We have a lot of really large earthworms in northern Australia, and you see the size of these animals. They're actually they're frightening, actually. They're too big. They make slurping sounds when they go back into the ground and stuff at night. It's frightening. The whole country is just... Yeah, they're called... Ken says, Bob, it's a snake. You know. No, that's the ones I'm really kind of watching out for. Next slide, please. So here is the food web. We looked at it in a more complex form. It's just to say that this is really what we're feeding. We want to put carbon into this. Here's organic matter coming into the system right here on the left. And it's feeding both the bacteria, fungi, nematode, and protozoa. What's hidden in this chart is that this is representing prey and predator. This is representing the mineralization of organic matter and releasing nutrients. It's hiding the 7 functions. So we'll go to the next slide and start to look at those functions a little bit. Here's the example of what's going on in the food web. It's a big amoeba. I've been told by my students, I bring students to my farm. There's 5 universities on the mainland and University of Hawaii that if students come, they study with me. I teach soil classes on Tuesday and Thursday at 1 o'clock, and they can get credit for those classes. One of the students said, I don't want you to ever show that again. During the day, I had nightmares the whole night about the nematode, about the amoeba. But this animal is perfectly designed to go down through the water film with its mouth open, gathering up bacteria, consuming them, and then excreting out a higher percentage of nitrogen than they need for their health onto the... Where is this animal? Where is this happening at? If I've got a protozoa or a fungi, if I've got a protozoa like this or a protozoa like this, where are they? In the liquid. Thank you, Mark. No one answers that question, right, amongst farmers. I've asked 10,000 farmers, where is this happening at? It's in the fluids. They have to be in the fluid, and that fluid is on the clay and the humus in the pore space. All the action, including where the root is in the pore space in soil. That's where the water is, it's where the root is, it's where the rhizosphere gets developed. Next slide, please. This is showing fungi. It's hard to see fungi. This is showing fungi, and there's 2 aggregates that have been enlarged, and the white threads are the fungi, and they're trying to pull those aggregates into an orderly structure. In the aggregation process, where bacteria start out by putting out gums and glues and gels and sticking particles, sand, silt, and clay, together, and then something happens, and I don't know if it's exactly understood. There's something that happens in the older literature. It was a complete mystery. It might be answered more now. There was something about that bacterial activity with their polysaccharide production starts to alert the fungi that they have work to do, and they become more active, and they start to wrap the aggregate in their hyphae, which is chitinaceous. It makes the aggregate tougher, makes the aggregate so it doesn't fall apart, and it is the aggregation that then forms the pore spaces. So if we all at this table come into a little orderly structure and we hold hands, that's like aggregation. We're coming into a structure where there's air and water and where the root can come in and feed off of these materials. Next slide, please. So here's the services that we're looking for from the bacteria, fungi, nematode, and protozoa in soils, and from the whole energy that's created in soils by the life forms in soil. Next slide, please. This guy's on the surface. He's one of the 9 animals. You see the leaf that he's standing on has that frayed edge down at the bottom. They have mandibles. They're just like little cows. They're like tiny little herbivores. And they're in chewing up the organic matter to get it into small enough pieces to lie on the surface and go in. Or what they do is they consume this material, and then like little cows again, they deposit their fecal pellets on the surface. That material can get accessed by the bacteria at that point when it lays on the surface and act as food, a very high quality food for the bacteria that we need to aggregate our soils and to keep healthy soils. Next slide. Beetle larvae, next slide. The mites that are in soil in the next slide. And we get to the 7 functions. I started doing these 7 functions back in year 2000. It was extremely frustrating for growers. They thought this was fastidious. We really couldn't understand it at the time. But now I think that we need to understand that it's by feeding carbon into the soil that we start to get these services. I put disease prevention in black because, you know, in a topic where you're talking about soil health, I'm looking always for the bridge over to talk a little bit about disease too, the other side of health, okay? I never intended to deal with plant diseases. I was not accustomed to it. I will attribute some of that to the size of the farms that I had when I was younger. I thought, we're not going to have problems with diseases and pests. We were small, we kept rotating, we were diverse, and we didn't care if there was a little bit of foraging. If there was a little bit of pest damage, that was okay, just because of how we were. But now I work for conventional farms, I work for larger farms, and all they have are diseases and pests. And so this puts me solid back, needing to execute soil health principles and move in a direction where I get the services and the functions of soil working for me, because this the disease prevention from soil, if we don't have that, then forget it. All you're doing is doing topical stuff then, and intervention, and it doesn't work. It's too expensive, doesn't work. We have to have the soil and the plant both healthy to protect themselves, just like ourselves. Next slide, please. Plant growth promotion is huge towards fruit quality. This material, because of the soils delivering more nutrients and delivering oxygen to the plant's roots, there can be great gains to plant growth. Chemically, bacteria and fungi producing humic acids or organic acids and signaling molecules. These are secondary materials produced by the plant. They're not needed for its primary protection of its life, but they're used for other purposes. And at the bottom here, and you can change slides, this is a really interesting material, pyrroloquinone, let's call it PPQ, so we don't have to do that again. Is produced by soil organisms on the roots. It's a plant growth promoting rhizobacteria, PGPR as we like to call them. It's Pseudomonas florensis. When this organism is on the roots of your plant, it puts out a secondary material that elicits the plant into having more flowers, more fruit, larger fruit, and puts more antioxidants into the fruit that's growing. That helps our health. Next slide. All produced by bacteriums in the soil. In terms of soil-borne diseases, we're looking for, next slide please. We're looking for the suppression of pests by natural means. In other words, we want to employ that which is given to the plant, that which the plant can do, and that which the soil can do on their own to protect the plant. And really, it's not the pathogens so much. Look, I have viruses and things, and they don't bother me unless the level of my immunity gets low. We understand this for ourselves. It's the same for the plant. And so this is what we're trying to do. Plants do not have an immune system, but they have an active and a passive systems for protecting themselves against diseases. Passive, for example, would be bark and lignin and hardened surfaces. Active would be some of the things we're going to look at. So next slide. So this is a disease triangle in a graphic form to make it a little more friendly. It's looking at 3 corners of a triangle, if you will, and saying that as long as we have all 3 circles working for us, we're going to have the things that are in these circles, we're going to have minimal pest damage and reducing the pest numbers. Next slide. Here's another view of, you can use these triangles. This is called a disease triangle. I never used this. I used to talk about diseases without the use of this, and one time a pathologist came up and he said, I don't believe that you do that without disease triangles. And I said, I don't know about that, tell me. And so we go to this to act as a graphic way. Say if this was the 3-legged stool here, you know, if you break one of the legs, it falls over. And so the analogy is if we can break one of the legs on the triangle, we'll have less symptoms and maybe absence of the disease, will have a tolerable, manageable level of the disease, let's say. And so cover crops, for example, that we're talking about here today as a carbon source for soil health and for the organisms in soil, the cover crops alone can break the disease triangle on all three legs in a number of ways. I have charts, and you can do one for this. This is a very handy tool. You can ask questions about yourself and your own health through a disease triangle kind of a setup. But you can do this disease triangle just like this for cover crops, for compost, for mulches, for using minerals in the soil appropriately, and for tillage. And in all three legs, our little method, I'm calling it our method because it came out of the last 40 years or so of farming, that we finally arrived together as farmers, realizing that we need to bring up the level of the health of our soil. We can't have it eroding. It's a precious resource. We have to have it healthy, and that'll produce our best crops. It's our best chance for our health is to produce nutrient density and true quality in our food. Next slide. So the manipulation of the native antagonist is what we want. To the extent that I can, I don't want to start to introduce things that's all cost, it's all effort. If I can bring up the level of the bacteria, fungi, nematode, and protozoa and their activity and their health, it's going to greatly help me to keep from having to introduce something. But pests are complex. The whole system is very complex. And I'm treating it kind of at a surface today and not getting into treatments, not getting into the sort of the agronomy strategies, but just trying to set the basis by which all of us can have healthy soil that'll raise a decently healthy plant, and then we can put treatments on top of that. We don't start from the top down, we start from the bottom up. Next slide, please. Different types of suppression, next slide. We have parasitism and hyperparasitism that's available to us to help us with our pest problems. They're in the soil, okay? And what we need, again, is carbon in the soil and space. These organisms have to have a place to be. They want to be on the roots. They want to be on the rhizosphere, and the root wants to be in the pore space, right? We're here in a pore space. We've got water, we've got air, we've got a place to be, we've got plenty of partners around us. This is a great example of the pore space, us being right in this room. The root is in the pore space. That's the only place it has to be. It doesn't try to go through the wall. It doesn't try to go through a rock. Roots travel the path of least resistance. They're going to go into pore space, and in that pore space is where we can have these parasites and hyperparasitism capable organisms to operate. Next slide. This is the hyperparasitism in action from Kona. So I just took this slide a couple of days ago. So the orange is the coffee leaf rust that was introduced a couple of years ago. It's a consummate predator on coffee. It grew up with coffee. It understands coffee very well, follows it around the world. I have found that not only does the lacani, this is the entomopathogenic fungi lacani. There's hundreds, possibly dozens or hundreds of types in Hawaii. If it's humid enough and you have coffee leaf rust, it'll attack it. There it is. In Central America, in their more humid regions, for organic farmers and sustainable farmers, it's almost, I shouldn't use the term sustainable, biologic farmers, it's almost all they need. They use the lacani takes the spores down. The spores are very nutritious. I found a mite also in Kona. All the farmers have seen it. There's a mite in Kona that's consuming the spores. They're beautiful. They're the same color as a spore. They have translucent bodies and you can see through them, and they're the same color as a spore. So next slide. So we have lots of these active animals here in Hawaii. By 1920 in Hawaii, there was great publications, they're still available online, that in Maui land and pine was having a lot of trouble with nematode, plant parasitic nematode. And they introduced in a trial, the sitar, introduced pineapple tops, chopped pineapple tops into the soil. Just for a moment, I'm into introducing any type of organic matter I can into soil, but there's differences in quality. If you introduce compost into soil, watch what happens compared to adding chopped up raw pineapple tops. You'll see a quantum difference between adding compost compared to pineapple tops. But they chose to add pineapple tops because that's what they had. It was organic matter. And guess what happened? They decomposed, the bacteria attacked them, the fungi attacked the organic matter, they brought out the nutrients, and in this interaction, the nematode trapping fungi was supported and was trapping parasitic nematodes. In 1920, we knew this, and we knew that feeding carbon to them was all you had to do. Again, feed compost to them, feed cover crop roots to them, non-host cover crop roots, and appropriate mulches. Next slide. This is a predatory nematode that we see in the soil food web. He's a very large nematode. He's eating 11 other nematodes. A horrible image. Let's do it again. Next image. Especially near lunch. Yeah. We did this once. I don't know why it's here again. We can go around it. Next slide, please. So we had the big predator nematode being shown there. So we were talking about specific suppression. There's also general suppression. This gets tedious. It's just saying that, look, there's a number of ways that we can get disease prevention from soil health. Next slide, please. PGPR are a big part of our soil health. If we are to keep diseases off our plants, then the healthy soil has to provide plant growth promoting organism. Next slide. There's a lot of them. The Azotobacter, I tried to put it in bold, not very well lined up. The Azotobacter is one of the larger plant growth promoting bacteria in the soil, and they require a lot of oxygen. So if we have compacted soils, if we don't have diversification of our pore sizes, pores in the soil, we want small ones, we want medium-sized ones, we want large-sized ones. Kind of like in your house, you got different storage areas. You got a small little cabinet, you got a big closet. There's different areas. There's a fridge. We put certain things in there. We put certain things under the table. There's all these different storage areas. And in the soil, it's the same situation. Remember, the pore spaces in the soil and some of the small pores are where beneficial bacteria and fungi can hide from their predators too. Okay? And so the diversification of the soil's pore spaces is really important. The only way we're going to get there is with amending our calcium levels correctly, getting to tap-rooted plants, and getting enough carbon in the soil so the soil can naturally aggregate into a diversification of pore spaces. 5 minutes. Okay, we better go past this. Next slide. And next slide. This is just showing some of the mechanisms. Aggregation is so important. Let's stay here for a second. I already talked about aggregation. It's how we're going to get our pore spaces, right? Okay, next slide. Aggregation at work. This is actually, these aggregates are so stable that they won't slake. They won't break down hardly at all. And this is part of the problem is we get our soil tests back. A lot of times we get soil tests and you get it back and you go look at that line on the organic matter and it goes over 20%. Oh my gosh, over 20%. And the inference of that is that, wow, I've got all that 20% and it's all active and working for me. It's going to give me nitrogen. It's going to give me carbon. I don't have to have carbon in my soil. I've got 20% OM. Lab says it's excessively high. Not all of that organic matter is available. A lot of it is in hardened aggregates, such as these. I slake these, I put these in water and let them sit, and I shook it. They won't break up at all. And the roots can't get into them. You see the roots are not going into these because they've hardened themselves too much. It's a phenomenon in tropical soils that can actually be difficult for us to overcome. The point here is to keep adding carbon to your soil. Don't stop adding carbon because your soil organic matter levels on the soil test are high. Next slide. Next slide. Next slide. Okay, let's go through these as quick as we can. Next slide. Go ahead. Change it. Nutrient management. So we're going to get to soil tests. Soil tests are actually very tricky. I've studied them for years. I look at thousands of them. They can fool you really well. They can give you a false sense of confidence. And they can tell you the wrong thing unless you practice with them. This is just trying to show what happened in 15 years of cover cropping that I did one time for a small, this is in California actually, it was a small vineyard, and we cover cropped it on this side, it was about 2 acres. On that side we did not, a couple of acres. And over 15 years, there was quite a significant improvement and nothing negative that happens from the cover crop. Next slide. This is a great book. I recommend everybody get a copy of this and check it out if you're interested in nutrients in your soil and what's going on with minerals. Organic matter management. Next slide. So we get to this that we won't spend much time on, just to show from Brady and Weil, this is good science, from organic matter being applied to the soil. I counted those. There's around 35 benefits that start to happen from simply applying organic matter. And remembering that compost is one of the highest forms of organic matter that you can apply. Next slide. Humus is what we want. Humus is the fraction of soil that's the most decomposed. It has a very high CEC. It holds water really well. Next slide. It holds water really well, which is hugely important. That's humus that you see on these roots largely. Of course, there's regular carbon in there, but a lot of that is humus because it's formed by root activity in the soil food web process in the rhizosphere. So it's the water holding capacity of soil organic matter and humus in particular that we're looking for in soil. Next slide. In talking about getting the services of soil by putting carbon in the soil, we're using our cover crops, we're using our compost, we're raising lots of bacteria. There's always been an issue in farming that we didn't know if plants could really uptake proteins. Okay, we believed that the proteins had to be broken down by bacteria and fungi and to come out to amino acids and get into a form that the plant could use them. But next slide. Dr. James White was hired by a client. So I worked for Bayer's biological division in Australia for many years. And they supported our research on soil health very well. The whole topic that I was assigned to was to help with the replicated trials that they were doing to show that inoculants, organic inoculants, work to help soil health. And we found that we had to grow cover crop, we had to apply compost to get the best effects. And we hired Dr. James White to describe to us his new research. We did this on macadamia, we did this in macadamia and in avocados. And what he had found was that it's the bacteriums on the root hair that's really causing the root hair to grow. If you remove specific bacteriums from the root hair won't grow. Next slide. And so this is Dr. White's work. It's called the rhizophagy. And it's simply, he's proven now, you can find this online, it's a little tedious, but bring it up because this is part of the feeding that we're looking for from our soil health. So we know now that root hairs have a mechanism in their interaction with bacteriums to open up at the tip as they're growing. And they take, the plant root tip takes in bacteriums, strips them down with reactive oxygen, consumes what it needs, ejects those bacteria back out that feed the bacteria at the root tip, continue the process, and the plant's literally using whole live bacteriums as food. Next slide. Here is another example of what's going on. It's out at that tip of the root, that tube is representing a root. You see the root carbon is being exuded and root hairs cells are being sloughed off. This was the old model about how the root went out into new soil and started to explore the mass soil. Because remember, the root has all this beautiful stuff that is built up around it, but it's all the time out, heading out into new space. And so it's the root tip, now we know, can actually take in the bacteriums as it explores new pores and new space and get its food. This answers a lot about root growth. Next. And the health of the bulk soil, most of the time, like back on that slide where I showed out in the tractor row, the soil was actually better. But a lot of times the bulk soil out around the roots is lesser quality, it has less health. And so the root is going out into that soil that has less to give it. And so, but it's looked at as that bulk soil is the next source of enrichment for the root. Next slide. And we'll go to compost for a minute. That's my, she's gone now, that's my 35-year-old compost pile. I used it for 35 years. I fed it every day. I protected it. It's protected right now. You can't see it, right? You're not supposed to show your soil to anybody. Soil's modest and it needs to be covered up, okay? It doesn't like to be naked, overheated, and overworked. And so my compost is covered. And my compost was fed every day. I fed it other people's compost. I fed it bird nest. I fed it mud from rivers. I fed it everything for 35 years that I could find. Sometimes we'd take it apart and let it die, and then we put it back together within a short time. I was trying to build diversity into it and resilience into it, and I'm practicing. I'm a composter. I've got to practice, so I practice on this pile every day. Next slide. I work for commercial compost places. This is thermal composting. We could do it at home. We do it with a tractor. Next slide. But that's different than the static composting. That was the old pile that we looked at first. Here's the classic paper. So Dr. Paul Hepperly is my good friend. He was professor for pathology here at the U of H back in the day. We made acquaintances and we've been friends ever since. And Paul was the research director at the Rodale Institute. And during, I think it's 2000 and what was it? I forget the year, they published their research. It was a 35-year research. We also have the Russell Ranch in California that in 2019 published their blockbuster 35-year USDA watched research. I've taken groups of 12 Australian farmers 3 times to the Russell Ranch in California to look at it, to talk to the Denise there. And what they found both at Rodale and in California was that our system's working. Composting, organic matter, decent amount of minerals, less tillage on the soil's working, okay? This is us coming out of being small farmers. We could see this happening, and now it's become a peer-reviewed 35-year research from different groups. There's 5 or 6 other groups around the world that have long-term trials. They're all showing the same thing. We're on the right path. What we need to do is practice and learn. Harry Hoytink, Dr. Hoytink at Ohio State University was the first one to come out. He was a pathologist. He came out and made the blockbuster statement that the compost was controlling diseases. I called him on a dial-up phone and I asked him, I said, why did you do this? And he said, because people like you were always calling me and telling me that pests could be prevented by compost, and I decided to end it. I'm a pathologist. That wasn't going to happen. And he found out just the opposite happened. And this started the whole revolution of disease-preventative potting soils built from hardwood bark. Next slide. Next slide, please. This is Paul Hepperly in 2009 telling us about cover crops and how they actually produce so much more. Look, I love compost. I absolutely love compost. I can't get away from it, and I'll admit the truth, but it doesn't have roots. It doesn't have roots. And so I started to teach cover crops. I started to put examples all over California, demonstration. Napa Valley College hired me to teach, be instructor for cover crops at Napa Valley College. That gave us great opportunity to do demonstration through the northern wine grape production regions. And here in Hawaii, I love plantain. Plantain is a perennial. It's highly nutritious. We grew millet. We grow, you just roll through lots of plantain. Here's Quite Coffee Company. I went into old trees and just tilled just a little bit. I put black oat. I put the long type fodder radish. Next slide. There's both non-host buckwheat. It's used all the time in Hawaii, of course, and gives us a little extra phosphate. Sun hemp. What a workhorse plant. If you don't grow sun hemp, go get some seed and try it out. I'm having great success, in my opinion, with sun hemp. That's just lying it on the ground. I just take fields that have been tilled for whatever reason. Sometimes these are weird developments or whatever. I just chase around the tractors and stuff, watch what's going on, get the seed and throw it on the ground. The birds will come eat everything except this. The sun hemp seed they don't want to eat. And so they go ahead and they germinate right on top of the surface. I do nothing to them but throw them on the surface. Next slide. course, we grow cover crops, then we got a source for mulch. Mulch is so powerful. Next slide. It has so much influence. Here I took just, I didn't grow cover crop and use it for mulch. I brought wood chips for a demo. And the mulch was put on the right. You can see the lesser growth to the left. This is not a setup. I mean, there was a half acre on that side. There was a half acre on this side. All of the mulch improved the environment in the soil, allowed the bacteria and fungi to pull off their 7 functions for the roots, and the plant was improved. Next slide. Lack of mulch, here's where we end up. You know, those roots did not grow like that. I can take bananas. You want deep mulch? Take bananas, grow them up. The guys from Colombia used the great big bananas. Come in, let them grow up, cut them down, let them decompose, come back. I've got mulch. I've got improved soil health. No problem, right? Just put a little slip in it, put my plant in, off we go. Next slide. We're losing our soils from tillage. We're losing our soils from not having cover on the soil. Not having cover is bad, but it's the tillage. Once you till the soil, then the wind, in particular, can get at it easier and shear it off and start blowing it around. That's not my slide. I don't know how it got in there.
It's like
Yeah, I might be getting cut off. Okay, next slide. You tell me. So this is just showing how the surface so much affects what happens in terms of loss of soil. We took three pastures, went into the pasture, bought a little sod from it, set it up on this little device. Now we can run water onto it just like rain and watch what gets caught. And you notice where there has been continuous grazing, saying that that's not right. We shouldn't continuously graze. We have to graze with technique. And with technique, we can almost eliminate the movement of soil horizontally on our farms. That attracted so much attention. That was in Maui. The USDA came. We set it up at the Farmers Union conference, and that was so attractive. There was just people constantly around this, looking at this example. Okay, next slide. I took sunflowers and grew a big field of sunflowers, and then I let them go completely dead. So now I've got lignified tissue. I've increased the half-life of this tissue. I want to take my cover crops, and if I can, I'll let them go completely woody and put them down on the ground. Now I've got coarse mulch. I can come back and throw small seeds into that and get a second crop coming up through it. I'll just keep throwing seed if I'm allowed to, and keep growing up through it. I'm doing kind of a rotation in place. You know what I mean? I'm diversifying it by throwing different types of species. I can come and throw some minerals to that. But the purpose here was to cut it into alleys. Now I can come in and put transplants in that. I've got windbreak. I've got a shelter belt. I've got mulch. Okay, next slide. Dr. Atu, Dr. Kumar, Atu Matar Atu, Atar Matu. I called him also, dial-up phone, talked to him, and I said, look, this is great. You've got this going right, but I'll bet because I go back to my system. I go, wait a minute, where's he breaking my system? So he's doing mulch, but he's not doing minerals. He did cover crop, he did mulch, but he's not doing minerals. Tillage, he's got that. He's not doing minerals. I said, look, I'll bet if you would get your calcium, magnesium, and get a reading and put a appropriate mineral treatment on that, you're going to get a lot better results. And he said, wait until our next test. He said, that's exactly what we're going to do. They took his budget away. This is working much too well. Okay. Yes. Okay, tillage. Let's go to tillage. Oh my God. If we're running at lunch, we can quit. This is where tillage, this employs me. So if you use that for a few years, I get calls. Hey, there's something wrong. I go, what is it? I go, well, I don't know. There's something out there. There's something wrong. So we start asking questions, and we end up back at cover crops, okay? So these are the nice big radishes. There might have been other people, but 12 years ago, I started introducing growers in Australia to actually seed that was being grown in New Zealand and in Australia, but they weren't using it. Winfred, Graza, Hunter, all these cultivars of non-GMO, hybrid, really strong tap-rooted plants. These plants, this is growing on Kauai Coffee Company. I put these in the ground. Now that doesn't look like that big a root, but that soil is as hard as this. It's rock hard. You can't get anything into it. You can't dig a hole in it with a shovel. I'm still pretty strong. I can't hardly dig a hole in it. these plants will grow into it and start to loosen the soil. Winfred and Graza from the PGG Seed Company are powerhouse cover crop plants. Next slide. Winfred. It's a grazing plant too. They're actually grazing brassica. They are non-host to most nematode. And I'm trying to do polycultures always. I'm trying to plant a forb, a legume, and grass. This is a forb. These are two forbs, but you can't be perfect all the time. But I like this combination. Next slide. Prento peanut under coffee is a winner. I want it under mature coffee. I don't like it around young coffee trees. It's too aggressive. And questions? There might be more, but I better take questions. Yes, hi.
Do you use hugelkultur? Do you recommend it? Do you like it?
Do I use what?
Hugelkultur, like burying of mulch.
Okay, do I bury mulch? Typically not. Maybe green manuring. Is it what's really green manure, burying green mulch?
Like logs.
Oh, logs? No, I've heard of this, but I haven't done it.
Oh.
Any other questions? Yes. How about fenugreek for a cover crop for Hawaii? So the first thing I would look at in a plant that I'm not that familiar with is, okay, is it host to a disease or a nematode that I'm fighting within my soil or my crop? So I'm going to qualify, okay, does fenugreek host nematode? Usually it's nematodes I'm worried about. And if it doesn't, then I think fenugreek's a legume, isn't it? It's probably a good grower. I would think that you could use it as cover crop. I'm sure you could, actually. Right plant, right place.
Scum and seaweed as the top dressing.
Seaweed as top dressing. Do we use seaweed as top dressing? Yeah, I can take kelps and put them on the ground. Maybe, I can. Absolutely. It all has, to me, okay, so I'm questioning, can I put chopped up kelp on my ground? I'm going to question the amount. You're going to put that much? No. If I'm going to put a little bit, yeah. I'm going to plant a cover crop on top of it and let that sit for a while. It'd probably be quite beneficial, or it could be beneficial. Uh-huh. How does biochar work in the food web, and how can we see the results, or how can we? So how can I get the best results applying biochar, and what's it do in the food web? Because, let's just call it charcoal for the moment. So it's activated charcoal, it's been over 500 degrees. There's lots of charcoal in the soil. Historically, if you go down and look and you fractionate it and float it out, there's quite a bit of charcoal in the soil from fires, from humanity, and from just wildfires. And when the charcoal is formed by fire, by heat, it becomes stabilized. And so that carbon in the soil isn't really feeding the food web much. Now, it seems to be like the research right now, the Australians are just crazy about biochar, and they got all this research. Try reading some of their research. I think that what I believe right now is that introducing biochar into the ground might give us some water holding improvements. And that's about, it might improve drainage. Yeah. And so it's the cost, usually has been the cost of biochar to me. I'm pretty much on cover crops to get that infiltration and to get carbon in the soil and to get something that can actually feed the soil food web. Okay? Yeah. Okay. So if I've got a perennial cover crop, is that sufficient? Because it's perennial, it's always there, it's not giving enough. Remember, a lot of the action of the cover crop is a plant. It's a plant. And so what it's doing is photosyntheting, it's building the capacity for it to push a lot of the carbon and a lot of sugar that it feeds back into the soil. So that perennial peanut, it sits there and it looks like it's not doing anything, but the real action is in the roots. Yeah. I would prefer to graze it. Yeah, we mow it, we can mow it, but we didn't get to animal integration. I feel guilty I didn't mention animal integration. If we can graze it, that's really great. And the animals benefit very much from the peanut. Yeah.
One of the things been in the news is plants concentrating heavy metals and forever chemicals and so forth. Do you have any comment on the long-term preservation of soil given those threats?
So the gentleman asked the question, basically asking, well, there are plants that are accumulators of heavy metals, of certain materials, such as carrots. And what do we do about this? Yeah. We want to have we want clean soil. We want to try to grow food on clean soil, of course, and so it's avoiding the pollution of that soil best we can, keeping old tin, metal off the soil as much as we can, not applying things that could be possibly long-term negative to us. I'm not sure how to answer that.
Yeah, soil mitigation, regarding soil mitigation, so contaminated soils.
Oh, I see. Where we grow, okay, so there is technique where carrots are used a lot. There's a patent actually on carrots that was filed where they grow the carrots, it would pick up certain metals and then you export them to the dump. Probably not a bad idea. This is all the pain of pollution, of course, and all the damage that we did that we're trying to remediate. Yes? I haven't had, excuse me. So, if I understand the question, have I had fungi interrupt the cover crop? Pathogens. Oh, okay, if you want to, okay. Oh, perfect question. Okay, now I'm not, okay, so basically what supports fungi? Okay, so fungi have specific enzymes that they can use lignin. Lignin is the material that makes wood hard, right? Wood is hard because of the material we call lignin. And that lignin is the food for fungi. They're one of the only things in the soil that can consume it, actually decompose it. And so if I want fungi, then I'm gonna try to let my tissues lignify, like those sunflowers that I showed you. Yeah, that was the purpose of that. I've taken sun hemp. Bob Joy looked at one of my stands of sun hemp once. He was a raiser, a breeder of sun hemp. And we were 100 yards from my stand. He said, oh no, you planted them too dense for one. He said, they're all stuck together and they're tiny and they're skinny and tall. And he said, then number two, now they're all turned woody. And he said, you're not gonna be able to get them down. And I said, well, I did this on purpose, Bob. Yeah, because I wanted the lignin in that material. I wanted the lignin, and then I lay that down on the surface, let it start to decompose, and that's great fungi food. In fact, we sent it in to Brian Bush at the university after 2 weeks after laying down sunflowers and or sun hemp that had become woody. Once the sun hemp actually sits there and becomes woody, you can slash it with a strong mower and put it onto the ground pretty easy. And we sent the sample from that soil into Brian Bush, and he made the comment that he had never seen such density of saprophytes, those fungi that are consuming dead plant material. I hope that answers that question. Lunchtime. Thank you very much. Aloha.
Thank you, Bob.